Alright, so today we're going to be learning about the distributive property with rational expressions. If you're keeping track in the book, that would be lesson 39. We've already learned a little bit about the distributive property, so now we're just learning how to do it with rational expressions. And what a rational expression is, rational, you should be thinking fraction, just like rational numbers would be numbers that are fractions, and expression would be something with variables. So it means we're using letters in fractions with the distributive property. A lot of this is stuff we've already done, just combining it together, using things we've done separately, doing it all together. So looking forward a little bit, just a sample, jumping right into this, we could have something that looks like x squared over y squared times x squared over y plus 3y cubed over m. So we know how to distribute this. We're going to take our first term here and distribute it over there. And what that is going to look like is x squared over y squared times x squared over y. We're going to take our second term. I'm going to highlight this with green this time. Take this over to our second term. And what that's going to look like is 3y cubed over m times x squared over y squared. And we just took this plus sign and brought it straight down. That's where that came from. So we do this multiplication. We have x squared times x squared on top. When we're multiplying fractions, we just do it straight over on top. X squared times x squared. That's going to be with our product rule for exponents. We have two x's here, two x's there. We add those. We end up with x to the fourth. Just like that on the bottom as well, we have y squared times y. Do that on the bottom. 2y's here, 1y there. We end up with y cubed. Then we're going to add over on this side everything we do over here. 3y cubed times x squared. 3y cubed x squared. None of those are the same, so there's nothing we can do with them. We just leave it. And we have m times y squared on the bottom there. What happens next when we're simplifying? We know we have 3 y's on top, 2 y's on bottom. That is going to cancel out a little bit. So we have 2 on bottom. We're going to take both of those away. We have 3 on top. So we're going to take those away, and we're left with y to the first. So what that is, if we have y to the cubed over y squared, y to the power 3 divided by y squared, that's going to end up being y to the 3 minus 2. Which is y to the 1, or just y. What we end up getting here is, that's the wrong thing. That should be an x to the fourth over y cubed plus 3 x squared y over m. And that's kind of our baseline example. After this, we're going to try it with some subtraction. So the problem I would like to try here, let's do this in a nice green color, is going to be m over z times axp over mk minus 2 m to the fourth p to the fourth. Awesome. And we're also going to distribute this. So I'm going to take this right here, and we're going to distribute it to this first term inside of our parentheses. That gives us m over z times axp over mk. That's a mouthful. And then we're going to do it again, and we're going to take this term right here and distribute it over to our second term. So what that is going to give us is m over z times 2 m to the fourth p to the fourth, and we have a negative sign here. That's going to carry down right to there. So continuing through this, we're going to do this multiplication. We have an m on top and an m on bottom. Luckily, those are just going to cancel out. So what we end up with is axp over zk minus, then we're going to have m times m to the fourth is going to give us m to the fifth, times 2, we like putting the coefficients in front, times p to the fourth, divided by z. We have our z right there. It's the only thing on the bottom. It stays on the bottom. And that's going to be our answer to that problem. The next one we're going to do we're going to try with negative exponents. Negative exponents. So this one is with negative exponents. And an example problem here, I'm going to use that really pretty purple I found earlier, is going to be b to the power of 3 divided by d to the negative 3 times 2b squared over d minus f to the negative 3 d over b. Wow, there's a lot of letters there. Don't worry, it's not as bad as it sounds, I promise. As usual, our first step is going to be taking this right here and distributing it inside. So we end up with b cubed over d to the negative 3 times 2b squared over d. Our negative comes down, and we're going to do our next distribution, which goes right there, and we end up with b cubed over d to the negative 3 times f to the negative 3d over b. Beautiful. So now we can do our multiplication. It still multiplies straight across. B cubed times 2b squared. We add those exponents. We end up with 2b to the power of 5. We're going to divide that by our multiplication here. D to the negative 3 times d. This is actually going to be d to the first. Negative 3 plus 1 is going to be negative 2. So that's divided by d to the negative 2. Then we're going to subtract. Our subtraction comes down again. And we're going to end up with b to the power of 3 times f to the negative 3d. None of those are the same, so we're just going to keep it. b3 f negative 3d divided by, now we have d to the negative 3b. None of those are the same either. d to the negative 3b. And now we can continue simplifying. None of these are the same. The b and the d are different variables, so we can leave those there. With 2b to the power of 5 over d to the negative 2 minus, over on this side I have b on top and a b on bottom, so I'm going to subtract my b to the 1 from the b to the 3, leaving b to the power of 2, f to the negative 3, that's the only f I have, and now I have a d here and a d to the negative 3 on bottom, so that's going to be another subtraction. 1 minus negative 3 is going to be 4, so I end up with d to the power of 4. And that is going to be my answer. And just so that we have one more example, we're going to try distributing with multiple operations. So my example here, the last one, let's do this in a wonderful maroon color, it's going to be ab over c squared times axb over c plus 2bx minus 4 over c squared. Awesome. So our first step here is going to be taking this and distributing it inwards, giving me ab over c squared times axb over c. I'm going to add, that comes down, and now I'm going to use shade distribute into our next part, which is going to give me ab over c squared times 2bx. My negative sign comes down, and for our final distribution, it goes to all three of these. We are going to end up with ab over c squared times 4 over c squared. So just doing this very quickly, what I'm going to end up with is a squared xb squared over c cubed plus a b squared x, there's a 2 there, over c squared minus 4ab over c to the 4th. And what happened there? My c squared times c ended up with c cubed on bottom. ab times axb, the a is squared, the b is squared, x stays the same. 2 comes out to the front, b is now squared, I have an a and an x over a c squared. Over here I have 4 times ab divided by c to the 4th. And that is already simplified. So we are all done. Thank you guys very much for watching this lesson. I hope to see your wonderful notes in class, as well as you trying this practice problem. Just going to have you do one. That's going to be fs over e to the fourth times fhs over d plus 2sk minus 7 over d to the power of 6. So if you can try that problem right there at the end of your notes and bring that into class, we should be good to go. I'll see you guys on class. Have a great day.